In this lesson, we're going to introduce the concept of comparative advantage and show how two people with different abilities can cooperate to increase their wealth. In the last lesson, we introduced Bernie and his cleaning service, and we discussed his productivity and his production possibilities. In this lesson, we're going to introduce a partner for Bernie. Her name is Ann, and she has her own cleaning service. We're going to find out that because of their different abilities, Bernie and Ann can form a joint venture and, in fact, do a lot more cleaning together than they can do separately. Let's begin by looking at Ann's productivity. Let's suppose that Ann has the following unit labor requirements. Ann is able to scrub a room in 5 minutes, and Ann can sweep a room in 5 minutes. The first thing you notice looking at this chart is that Ann is able to sweep and scrub faster than Bernie. We say that Ann has an absolute advantage in the provision of both services. Whenever you can do something with less effort or fewer resources than another person, you have an absolute advantage in the provision of that service. Because Ann can scrub faster, she has an absolute advantage in scrubbing. Because Ann can sweep faster, Ann has an absolute advantage in sweeping. Now, let's suppose Ann spends an hour doing sweeping or scrubbing. What is the maximum output that she could expect? Well, divide 60 minutes, 1 hour, by 5 minutes that it takes to scrub a room, and you get that Ann's maximum number of rooms scrubbed in 1 hour is 60 divided by 5, or 12. Likewise, if Ann wants to sweep for an hour, she can sweep a total of 60 minutes divided by 5 minutes per room swept to get a total of 12 rooms swept. So with Ann's unit labor requirements here and 1 hour's worth of time to work, Ann's maximum output would be given by this table. Just as Bernie can scrub a maximum of 3 rooms or sweep a maximum of 6 rooms, Ann can scrub a maximum of 12 rooms in an hour or sweep a maximum of 12 rooms in 1 hour. We can now take this information and look at Ann's production possibilities schedule. With 1 hour's worth of time, if Ann wants to divide her time between sweeping and scrubbing, what possible combinations of output can she get? Well, let's have a look. Here's a table then that represents Ann's possible output, sweeping and scrubbing. If Ann spends all of her time scrubbing, she can scrub 12 rooms. That means she does no sweeping. If she wants to sweep 2 rooms, that's going to take her 2 times 5 minutes per room for a total of 10 minutes. Subtract 10 minutes from 60 minutes, and that leaves 50 minutes. 50 minutes divided by 5 is 10 rooms worth of scrubbing that Ann can do. 50 minutes is long enough for Ann to scrub 10 rooms at 5 minutes per room. And so forth. The opportunity cost for Ann of sweeping another 2 rooms to bring her to a total of 4 would be a loss of 2 rooms worth of scrubbing. She'd be down to 8 rooms scrubbed. 6 minutes would be, or 6 rooms of sweeping would be 6 times 5 minutes, or 30 minutes spent sweeping, leaving her a half an hour for scrubbing. Divided by 5 minutes is a total of 6 rooms scrubbed. Notice that all of these numbers in this column, 12 and 0, 10 and 2, 8 and 4, and so forth, all of the combinations add to a total of 12. That's because Ann's opportunity costs are 1 room swept for 1 room scrubbed. How did I calculate that? Well, the cost of sweeping a room is 5 minutes of Ann's time, divided by 5 minutes that it takes to scrub a room. That means every room that Ann sweeps is a room she's not scrubbing. Her opportunity cost is constant. The opportunity cost of sweeping 1 room for Ann is 1 room worth of lost scrubbing. Likewise, because of this reciprocal principle, if Ann scrubs a room, that's a room that she's not sweeping. She spends 5 minutes scrubbing. That's the same 5 minutes she could be spending sweeping. So the opportunity cost of 1 room worth of scrubbing is 1 room worth of lost sweeping. Here's Ann's production possibilities schedule. Now, let's convert this production possibilities schedule into a production possibilities curve. Let's draw a diagram like the diagram that we drew for Bernie. I'll clear my pad here, and I'll move these numbers over onto the board so that you can use them for reference. Well, over here I've got Bernie's production possibilities frontier that we drew in the last set of lectures. And to remind us about Bernie's situation, we'll go ahead and put up his equation. Bernie's production possibility frontier is described by the following expression. The total number of rooms that Bernie can scrub is equal to 3, that is if he spends a whole hour scrubbing, minus 1/2 the opportunity cost times the number of rooms that he sweeps. Each room that he sweeps is 10 minutes, and that means that he's giving up 20 minutes divided into 10, or 10 divided by 20, or 1/2 of a room worth of scrubbing. We saw this last time. Every room that he sweeps is 10 minutes worth of time, and that's half of a 20-minute job worth of scrubbing that he's not able to do. The intercept tells you the maximum amount of scrubbing that Bernie can do, and the slope of the line tells you the opportunity cost of a room swept, measured in terms of lost scrubbing. So here's Bernie's equation, and here's his production possibilities curve. Now we can draw the curve for Ann. Well, let's start. If Ann does no sweeping and all scrubbing, then she can scrub 12 rooms. So let's put a dot here in her curve that represents 12 rooms worth of scrubbing and 0 rooms worth of sweeping. If she decides that she wants to do a little bit of sweeping, every time she wants to sweep an additional room, she has to give up a room worth of scrubbing. So that gives us combinations like 10 and 2 and 8 and 4 and so forth. And we get these points all the way down the curve. Every time Ann decides that she wants to sweep an extra room, she loses a room worth of scrubbing, until finally we get down to this horizontal axis where she's sweeping 12 rooms and scrubbing 0 rooms. Notice we can connect the dots here to find Ann's production possibilities frontier. So let's connect the dots. And just like Bernie, Ann's production possibilities frontier is a straight line. What does that tell you? What does it tell you that Ann has a straight line production possibilities frontier? It tells you that her opportunity cost is constant. Anytime she wants to sweep an extra room, she gives up 1 room worth of scrubbing. Why is her opportunity cost constant? It's constant because her time and resources are equally well suited to providing each of the 2 services. Ann would just assume scrub a room as sweep a room. She can just as easily, with her time and talent, do either. There is no change in opportunity cost. If Ann does more sweeping, she always does so by giving up 1 scrubbed room for each additional room she sweeps. Her opportunity cost is constant. Let's look at the curve here and see what we find. The vertical intercept of Ann's curve is going to be 12. That's the maximum amount of scrubbing that Ann can do. Down here, the horizontal intercept is also going to be 12. That's the maximum amount of sweeping that Ann can do with an hour's worth of time. The slope of the production possibilities curve is rise over run, or -1. That is, every additional room that Ann sweeps is 1 room worth of scrubbing that she no longer has time to do. You find the opportunity cost by dividing the number of minutes that it takes to sweep by the number of minutes that it takes to scrub. 5 minutes worth of sweeping divided by 5 minutes worth of scrubbing gives you the opportunity cost of sweeping measured in terms of scrubbing that Ann is not able to do. Every time she sweeps a room, that's a room worth of scrubbing that she gives up. The slope of the curve is -1. Now, one more thing to do before we start talking about comparative advantage. And that is, suppose Bernie and Ann were working independently of one another. What kind of outcome could they expect? Well, here's Ann's production possibilities frontier. The formula is the amount of scrubbing she can do is equal to 12 rooms worth of scrubbing minus the number of rooms that she sweeps. The coefficient on sweeping is 1. -1. That's the cost to Ann to sweep a room. It's 1 room worth of lost scrubbing. Here's Bernie over here, and we know that his production possibilities are represented by this equation. Let's suppose that Bernie and Ann are both running cleaning businesses and that they are working independently of each other. If Bernie and Ann work independently of each other and don't cooperate, then let's suppose that each of them has to sweep the same number of rooms that they scrub. You go to a house and it's got 2 rooms in it. You've got to sweep each room and you have to scrub each room in order to clean that house. So the question is, if Bernie and Ann have to sweep and scrub the same number of rooms each, that is, Bernie has to sweep, say, 2 rooms and scrub 2 rooms, and Ann has to, say, sweep 6 rooms and scrub 6 rooms, well, what numbers are going to work out? What's the maximum number of rooms that Bernie can clean by himself? What's the maximum number of rooms that Ann can clean by herself? Remember, the numbers have to be equal for sweeping and scrubbing for Bernie, and the numbers have to be equal for sweeping and scrubbing for Ann. Well, the numbers that work for Bernie, as it turns out, are 2 rooms. Bernie can sweep 2 rooms, and that takes him 2 times 10 minutes each for a total of 20 minutes worth of sweeping. That leaves him 40 minutes for scrubbing, and since it takes him 20 minutes to scrub a room, 40 minutes divided by 20 means that he has time left to scrub the 2 rooms. So if Bernie works by himself, then he is able to sweep and scrub 2 rooms each. So it looks like that point would be right here on the diagram. Bernie working by himself winds up scrubbing 2 rooms and sweeping 2 rooms. If Ann works by herself and she sweeps 6 rooms, that's going to take her 6 times 5 minutes each is 30 minutes, leaving her half an hour for scrubbing. Since it takes her 5 minutes to scrub a room, she can also scrub the 6 rooms. So Ann working by herself is going to be able to sweep 6 rooms and scrub 6 rooms. Now, if you look over on the board, I'm going to do a summary of this outcome. When they work independently of each other, and each one of them has to sweep and scrub the same number of rooms, then Bernie is able to sweep and scrub 2 rooms in an hour, Ann is able to sweep and scrub 6 rooms in an hour. Here's what you'll notice over on the board. I've done a table of what Bernie and Ann are able to produce when they are not cooperating. When they work independently, Bernie scrubs 2 rooms, Ann scrubs 6 rooms for a total of 8 rooms worth of scrubbing. Whenever they work independently, Bernie can sweep 2 rooms, Ann can sweep 6 rooms for a total of 8 rooms of sweeping. 8 total rooms get cleaned when Bernie and Ann work independently of each other. Next, I'm going to show how Bernie and Ann can increase the profits of their business. That is, how Bernie and Ann can cooperate and clean more rooms together than they can when they work independently. And this is where we come to the concept of comparative advantage. Here we have Bernie, and here we have Ann. And next to each of our players, we have their present production pattern. Bernie is sweeping 2 rooms and scrubbing 2 rooms. Ann is sweeping 6 rooms and scrubbing 6 rooms. Now, we're ready to introduce the concept of comparative advantage. Comparative advantage refers to your opportunity cost relative to the opportunity cost of someone with whom you might trade. We say that you have a comparative advantage in the provision of a particular good or service if your opportunity cost of providing that good or service is lower than the opportunity cost of someone with whom you might trade. Let's use an example now to try to make this concept very clear. We'll start by looking at the opportunity costs of our 2 players and look at who has a lower opportunity cost for providing the service of scrubbing. Let's start with Bernie. If Bernie scrubs a room, it takes him 20 minutes. Now, since it only takes him 10 minutes to sweep a room, Bernie's opportunity cost for scrubbing 1 room is 2 rooms worth of sweeping that he's not doing. So that's his opportunity cost. Now, you can also express this by dividing both sides by 2. His opportunity cost of sweeping 1 room is half a room that he doesn't then have time to scrub. So the opportunity cost for Bernie of scrubbing 1 room is 2 rooms worth of sweeping that he doesn't do. Let's look now at Ann's opportunity cost for scrubbing. Ann takes 5 minutes to sweep a room and also 5 minutes to scrub a room. So the opportunity cost for Ann of scrubbing a room is 5 minutes worth of time, which means sweeping 1 room. So if Ann scrubs a room, it's because she's not sweeping a room. Her opportunity cost of scrubbing 1 room is 1 room that goes unswept. Given this information, we know who has a comparative advantage in scrubbing. For Bernie, scrubbing costs 2 rooms worth of sweeping. For Anne, scrubbing costs only 1 room worth of sweeping. Anne has a lower opportunity cost for scrubbing, and therefore Anne has a comparative advantage in providing scrubbing services. Well, why should you care? Why should you care that Anne has a comparative advantage? Because comparative advantage is a guide to how Bernie and Anne can specialize and therefore increase their wealth. By specializing in trading, Bernie and Anne can clean more rooms than they can working independently. Let me show you how this works. Let's suppose Bernie decides to reallocate his time and specialize in sweeping, that is, to do more sweeping and less scrubbing. Why am I having Bernie do more sweeping and less scrubbing? Because scrubbing is relatively expensive for Bernie to do. He doesn't have a comparative advantage in scrubbing. He would like to work out a deal where Anne does more scrubbing because her cost is lower. Bernie will do more sweeping because his cost for sweeping is lower. Remember, when Bernie sweeps a room, he only gives up half a room worth of scrubbing. Anne gives up a whole room worth of scrubbing. So Bernie has a comparative advantage in sweeping, just as Anne has a comparative advantage in scrubbing. So let's have Bernie specialize according to his comparative advantage and see what happens. Well, first thing that happens is Bernie reallocates 20 minutes of time away from scrubbing and instead winds up sweeping 2 additional rooms. So with his newly allocated time, Bernie adds 2 rooms worth of sweeping and loses 1 room worth of scrubbing. Well, now he's sweeping 4 rooms and scrubbing 1. So he needs a little bit of help here from Anne in order to make sure that he's getting a full house cleaned. What he does then is he offers to trade with Anne 2 rooms worth of sweeping, those newly created 2 rooms, and see if Anne will give him some scrubbing in exchange. So what Bernie does then is give some sweeping services to Anne. He sweeps 2 rooms for her. Well, this now frees Anne not to have to sweep those 2 rooms herself. And with those rooms not having to be swept by Anne, she has 5 minutes here and 5 minutes here that she can now reallocate towards scrubbing. So Anne sweeps less and scrubs more. She moves this time into scrubbing and increases her scrubbing activity as she cuts back on her sweeping. So now Anne is sweeping 4 rooms, plus she's getting 2 rooms worth of sweeping services from Bernie, and that allows her time to scrub a total of 8 rooms. She can now give one of those scrubbed rooms to Bernie, that is, scrubbed one of his rooms, and he's just as well off as he was before. Now with this help from Anne, Bernie has 2 rooms scrubbed and 2 rooms swept. He's also sweeping 2 rooms from Anne, so she can scrub 2 additional rooms. And if you look, our total output now is 8 rooms worth of sweeping and 9 rooms worth of scrubbing. Where did this extra room of scrubbing come from? It came from specialization. Because Bernie specialized according to his comparative advantage, these 2 working together were able to scrub an additional room. They were able to turn out a little bit of extra labor relative to what they did before. So now Bernie and Anne have 8 rooms swept and 9 rooms scrubbed. Can they do any better? Well, probably so. Right now we've got an unequal number of sweeping and scrubbing, so we've got this scrubbed room that's unswept. Let's see if we can do any better. Well, of course we can. And what should we do? We should have Bernie do even less scrubbing. That is, here's the room that Bernie's still scrubbing. Let's have him take those 20 minutes and sweep instead. That way he can turn out 2 more rooms worth of sweeping services. This promises to be a good deal. Now Bernie is doing no scrubbing at all. He's doing all sweeping. He's got 1 room worth of scrubbing services from Anne that he's acquired, and now he's ready to give Anne 2 more rooms worth of sweeping. Once he gives her those 2 more rooms, Anne is now freed to scrub some more. She converts her time from sweeping away to scrubbing, and now we've got all these scrubbed rooms that Anne has done, and she can send one of them over to Bernie. Bernie's just as happy as he was before. He's got 2 rooms swept, 2 rooms scrubbed. Ann is scrubbing both of these rooms for him, and he is sweeping these 2 rooms plus 4 more rooms from Ann. But the total now that we've got here is 1, 2, 3, 4, 5, 6, 7, 8 rooms swept, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 rooms scrubbed. Well, we've got a little bit of an imbalance here, and the imbalance is that we've got more rooms scrubbed than we have swept. If Ann wants to be able to sweep and scrub equal numbers of rooms, then she might want to convert one of these scrubbings back into a sweeping so that she now has equal numbers of rooms swept and scrubbed. Well, look at this. Ann has now got a total of 1, 2, 3, 4, 5, 6, 7 rooms swept, 1, 2, 3, 4, 5, 6, 7 rooms scrubbed. Bernie has 2 rooms swept and 2 rooms scrubbed. By cooperating and specializing according to comparative advantage, by Ann doing more scrubbing and Bernie doing more sweeping, and by trading with each other, Bernie is just as well off as he was before, and Ann is better off than she was before. Now, is that necessarily going to be the case? Well, not necessarily. I mean, certainly since we have 9 rooms clean now instead of 8 before, the 2 of them combined are able to make more money with their cleaning business. Ann could stay where she was before and leave Bernie with 3 rooms clean, and Ann would still have the same 6 rooms swept and scrubbed as before. It doesn't really matter who gets the benefit. That will be determined by which of these 2 is a more persuasive bargainer. But the point that I want to make is this. By Bernie specializing according to his comparative advantage, and by Ann specializing according to her comparative advantage, the 2 of them working together, specializing and trading, are able to produce 9 clean rooms, 9 swept, 9 scrubbed rooms, rather than simply 8 as before. Now, let's take a look at the production possibilities frontier and show how this story translates into a graph.